Welcome to this video. In this video, I will show some uh, some stuff from the project uh, stock market price prediction using graph neural network. Right. So this is the paper that I am implementing as a demo. So I'll be just showing some information from there. I've created 7 or 8 previous videos. You can definitely check them one by one. Now, what will be the goal of this video? Okay, so what I will share is I'll be doing some reorganization. Reorganization, I think I did it. I just shared it. And some changes on the data side that I will share and see if I can do some further changes. I think data side, what I did actually, I tried to find out which data I will take, because there are data like NASDAQ, S&P 500, New York Stock Exchange. I have decided that I will be taking the NASDAQ. And then for each of the stock, I think the data ranges for many years. So I just try to see which years I take so that we have data for all of the stocks. So that is one of the things changed, and probably just for each of the approaches, different files. Those are some of the changes. Yeah, code cleanup, reorganization, sharing some on the data. Those will be the goal of this video. So let's share my screen. Yeah, let's share something else. So I believe you will see the Anaconda navigator. So CMD stellar graph is just an environment where I use usually stellar graph. Also network X is there. There are other libraries to work with graph neural network. So I believe you just only see the Anaconda navigator. I'm actually in the command prompt. I'll be typing and I'll be opening the Jupyter notebook. Jupyter notebook. It will open in Chrome and then I will share the Chrome screen. Okay, I want to go Google Chrome. Just give me a second. Okay, supposed to pause the rep. Okay, I believe you see the Google Chrome, the Jupyter notebook. So at this moment, let's see archive. It has some data. Yes, I have used it. I initially wanted to put all the data under data folder. Now, when I downloaded data from a Kaggle or somewhere else, those are usually in the archive, all the data, and then I take the data from there to data folder to use it. But somehow it looks like I ended up using the archive directly linked into it. But anyway, so let's see. So in the meantime, if you are following Pearson, Spearman, and then we Candle. So these three different files, I think for each of them, from the, let's say, there are some parent data set or mother data set, whatever you say. From those data set and the stocks there, we'll be finding some correlation between different stocks, right? I think I'll be thinking in terms of Pearson correlation data that is used here. I think Pearson correlation based graph. The data is there, mother data is there. From that data, by using Pearson correlation, we create a graph, and then we will be trying predicting stock price using the data. That will be done here. And from the mother data set, same data set, we'll be finding Spearman correlations among those stock data. And with that data set, we'll be doing some stock market price prediction that will be under this file. And for candle tau coefficient based graph, the corresponding stock market pricing will be here, right? Now, let's say, so yeah, these are three different data sets, right? From the mother data set. And then another thing is find stock, this one, I believe this is the one another that I will be using. Yeah, I started with this, then I created copy, and then this is the final one, right? Find stock tickers in news articles. Okay, so what happens? Financial news, from the financial news, depending on which company is mentioned there, and if the article mentions to stocks, they are correlated based on the create some graph, and they will be predicting some price. So it will be there under this file. Okay, and yes, and it also took into account the stock financial news articles, right? Financial news articles, and find stocks in there, and then it tries to create a graph out of it. Yeah. So okay, I believe I've said the right thing. Okay, and there are two March file. This March and this March. Okay, this March file, I think the raw stock data for each company, one file with the date and corresponding data, right? So there are, let's see, in NASDAQ, I believe it's 100 top technology companies or something like this. Yes. So I combine all of those system data into one file, and there's some reorganization of this data so that the machine learning models can reuse it. Okay, Python libraries can reuse it well, or my code can reuse those data in a good way. So one thing is multiple CSV files, and another thing is merge only matching. Okay, in this case, what I did, I actually identified stock tickers, right? Identify some stock tickers. Okay, this is the only thing that you want to merge. Okay, I want to merge those stock price data into one file. Okay, so the reason, yeah, I think one thing is NASDAQ has 100 stocks, but I may not always want to work with the 100 stocks because my data set will be larger, and then my machine can slow. Another thing is even the research paper that I'm trying to implement, so they have used only top 30. They told Fortune 500 top 30, but I'm using NASDAQ. Let me see. I may not think about the top or bottom. Just I will see. I can take 100. I can take 30. Okay, that's only one way. Just I will not use the entire data set. I will be using a particular set of stocks. So that is one thing. Another thing is, as I mentioned before, that not all stocks have prices for all of those years and dates, right? I try to see what is the common areas that everyone has data. Okay, so depending on this, I'll be selecting some initial selection the stock so that I have the data for the particular mentioned period, and then on top of that, I may try to shorten this list between 30 or 10 or 15 or 20 anyway. So this is only the matching one, and this is all of them. And also on another note, this financial news-based stocks, the original paper used 1 million articles, news articles. In my case, I'm not really sure I even have 1,000 news article. Let's say in this 1,000 news article, we need to say what are all the different stocks from NASDAQ mentioned in those articles, right? depending on that, I will need to create the graph and I will need to do it. So I think that sense only I can find out all of the stocks that are mentioned in this news articles, and I think I need to combine those data for only those from the raw data, each stock one file. I need to combine only those data that are mentioned on the news article. So a different variation of merging multiple files into one was important. So that's how this file was created. Okay, yeah, the other files are not really that much important. And usually under data folder, I keep the data files. Okay, let's say in terms of changes, right? Okay, I think this one got the major change. Okay. So let's say, okay, this one, and before that, I believe the merge only matching CSV files. Okay. So it is the regular merge. You can check the previous videos. You will know. You can say I have modified it, right? So here I am, whatever file is there, I'm just trying to merge them. Now here I am giving a list of the stocks that I am to merge, and you can see some of them are uh, turned off. Turned off simply because uh, they don't have the data for some particular period. Okay, let me see. For this, they might have data from 2016 or 2020 or something like this, but all others have data like 2005 or 2018, this range. So I just thought, okay, if I want to get more stocks, then I need to go back, right? So let's say I can select 2005 to 2008 or 2008 to 2008 financial crisis. That may not be a good point. Either uh, 2005 to 2007, or probably let's say 2010 to 2012 or 2013 that I can consider. Okay, so 2008 financial crisis, that is an anomaly. It's better that I uh, remove that anomaly if I want to just uh, take a couple of years. If I want to take long-term view, that's a different thing. In that case, I can still need to keep the uh, crisis data, and probably there's some sort of treatment for that or not, but that's probably the financial experts, they will know. But for now, okay, I'll be removing some. Let's see. I've selected some because those are mentioned in the stock news articles. The first selection came from the stock news articles, and then I'm removing some of this depending on the dates. Okay, so it is the same thing, right? So merging. So I explained this code before. Okay, now I'm just trying to find out. Let's see. This stock has the minimum from 2005. I'm just trying to who one has the oldest one. I'm just trying to what is the minimum date that is to particular stock has a uh, data for, right? So I started at 1900 and I traverse it, and I see if particular date is greater than the minimum, I take it. Then if another stock, the minimum date data available is already set minimum, and this becomes the new minimum. So for the what is up to which date, I think minimum of the maximum. Here I'm trying to find out minimum of the maximum. And here I'm trying to find out uh, maximum of the minimum, right? Yes, here I'm finding maximum of the minimum. Minimum date for each data is available for all of them, all the minimums. What is the maximum? Because if I count for that from that time, then I will have data for all of the stocks. And now as I removed some, they have the data 2016, but I want to go back. So I will discard them anyway, right? Now, what is this? This is the minimum of the maximum, right? For all of the stock, what is the maximum date data available for each of the stocks? Let's see, I have a list of all of the maximum dates for right. Then I have to find out the minimum, right? Find out the minimum of this maximum dates that ensures that I have data all of the stocks up until this data. So I have more than that, but I want to remove them. So this is what it is. Okay, so minimum of the maximum is 2012, 12, 12, right? So now I can just select some particular areas, particular years. I take the data from data, use it in the project. So that is the change. Okay, I need to do it because especially for these financial news articles, I'll not have all the NASDAQ articles there because I just considered a couple thousand. Let me see if the data size is there. If I, okay, it is not many. I believe it is 51. I believe, yeah, as far as I can remember, there might have some 51. 50, okay. Yeah, 51 rows. That means 51 different stocks data are available in the financial news. Financial news, I just identify the uh, sticker or stock, right? Company. And then from, I'll go to the data set. I'll grab this data from there. Okay, let's just review this. So, okay. Yeah, from the news articles, I try to find out all capital words because tickets are usually the all capital, but it does not mean that all whatever capital word is stock. Then I match with the NASDAQ stock tickers and then I find out the common ones, what is in the NASDAQ stocks tickers and what is in this news articles. That's those news articles are all about, right? Okay, then I needed to do some sort of manipulation because in the graph I need source and destination edge, right? Edge line between nodes and count how many times they appear in the news articles. So I need to find out all of the uh, all possible tuples for all the stock tickers mentioned in an article. For each articles, I find all the different tuples. And if the matching tuples, I increase the count to find out the, here it shows the how many times altogether in all articles they appear. Let's see, Apple and Amazon, they appear 20 times in 20 different articles, right? So dictionary counter combined tuple list. Okay, then source and as. Then I need to, this is the key, this is the value, right? This is the dictionary key, dictionary value. So from the keys, I try to separate them out and then I take the source and target, graph source and target, and then I create the age weight is the value 2013. Then, okay, just, and we will create the graph. Now to create the graph, I know what are the stocks and what are the edges in between. Now I need the price data. For the price data, I will need to go back to the merged file when I told for this selected. Then okay, after I find these stocks, then I go to here merge only, right? And then I put all those name here and let's read it and remove some that does not match with uh, date range. Then these things will be removed from here, right? Then I get consistent data in both files. So we can define all the edges and the corresponding weight, and that the price is available in the data set, right? Okay. Yeah, all merged. That is this one actually creates it eventually. Okay. Yeah, to CSV, right? Okay. Now there are some manipulations so that it fits into the stellar graph graph creation thing, right? Yeah, converting the data as data and sorting. Okay. Yeah, because we don't want it like for each one particular date price, right? We want it like all the prices in one row or one column. Yeah, I can just transpose it, then it can become the other way around. Okay, this is just to drop if in particular, if we say null value, we drop, but no, I'm not using it finally. I just need to see what exactly to do. At this moment, there probably will not be much much empty cells because I align the dates. I align the dates that are available, and usually they have the date in sequence, but that is something further verification, and then I'll fix it, right? Yeah, manual verification may not be enough. I think I need to write some more code so that it verifies that if there is any null thing or not. Okay, there are some tricks in setting operations, set operations. Okay, I think the set operations and everything, we're trying to find out the unique node to be used in the graph, and definitely the edges are there. Another thing is I also need to format it in a particular way so that I can feed the data into the stellar graph, right? That's why this data frame came into the picture. I actually needed to supply this transposed data, right? The data is like this, but I needed to supply it as a transposed the stellar graph data. Yeah, this is the node data. Okay, I think I was trying the without transposing, and I was facing some issues. Yeah, I think it probably took a little bit of time to figure out it. I think it could be shortened if I'd be looking at it, what format they want. Probably still things may not be always easy to see, right? Okay, so this edge comes from source target by combining into this data structure, and this comes from the data set. So this is the structure of the graph with some edge weights. Now this is the for each of the stocks, the time series data. It is there, right? Now I create the data. We can see there are 51 stocks, and then node features. And this is the edge type, edge features. Edge features are the weights. Node features are the stock market pricing data. So that's how I get it. Okay, I told that I'll be doing some code cleanup and structure. I think in the next video, what I can do. So this Candle is Spearman or Pearson. I think they might have some common data. Common data means Pearson had Spearman and Candle related some correlation or graph creation. They remove those. Now, this Candle and Spearman, they also have some sort of Pearson related data, and I want to remove this. Just code cleanup, that can be another video. Okay, see you soon. Bye.